Meta's revolutionary gesture-controlled bracelet, the future of computing. Imagine a world where the clumsy mouse and keyboard are replaced by a sleek wristband that captures your gestures and transforms them into digital actions. This groundbreaking innovation from Meta promises to revolutionize our interaction with computers, opening doors for those with limited mobility while making technology more intuitive for everyone. In a recent publication in Nature, researchers from Meta's Reality Labs unveiled their remarkable creation, the sEMG-RD, Surface Electromyography Research Device. This wristband utilizes sophisticated sensors to detect electrical signals from the motor nerves that travel from the wrist to the hand. By interpreting these signals, which are essentially the brain's way of instructing the hand to perform specific tasks, the device can execute commands that control connected gadgets. It's akin to converting your thoughts into actions, right on the screen, a fascinating leap into the future of personal computing. You might wonder about the origins of this project. The development of this technology is not new, it traces back several years. In 2021, Meta assembled a dedicated team, including notable figures like Thomas Reardon. His efforts focused on creating a gesture control device based on electromyography, with the initial goal of enhancing interactions in augmented reality environments. They started with simple tasks, such as replicating a mouse click, and have now evolved to the research documented in their latest findings. Interestingly, while there have been various attempts at similar technology, like a 2023 initiative that employed barometric pressure sensors to identify multiple hand gestures, or the Madra band designed to interact with Apple Watches using surface nerve signals, the sEMG-RD takes it to another level. It allows for comprehensive control not just of a cursor but of an entire interface. Users can navigate and select items with gestures like finger pinches, thumb swipes, and taps. The ability to input text by mimicking handwriting at a blazing speed of 20.9 words per minute is particularly impressive, especially since the average typing speed on mobile devices is about 36 words per minute. Another remarkable feature of the sEMG-RD is its capability to operate without individual calibration, although it can be adjusted for a more personalized experience. The researchers efficiently collected training data from a large pool of participants and used it to train a neural network. This system can accurately decode the raw nerve signals into actionable commands, meaning the wristband can be utilized by anyone without prior adjustments, much like how a conventional mouse doesn't need customization for each new user. The potential applications for this technology are vast. The team envisions advancements that could enable the wristband to capture the nuances of gesture force, potentially enhancing controls for devices like cameras and joysticks. Moreover, by further exploring different muscle patterns or signals for interpretation, who knows what novel interactions might emerge. This could significantly lessen the physical effort required to operate digital devices while paving the way for functionalities we haven't even thought of yet. Does this technology excite you? Or do you have reservations about moving away from traditional input devices? Share your thoughts in the comments below. Is it time to embrace this new era of technology, or do you believe the classic mouse and keyboard still hold their ground? Meta's Gesture Control Wristband. Control computers with sEMG hand gestures. Imagine being able to control your computer with just a flick of your wrist. It's a prospect that's both thrilling and terrifying at the same time. But here's where it gets really interesting. Meta researchers are actually developing a gesture-controlled wristband that can interact with a computer, and it's not just a concept, it's a reality. This innovative device lets people control a computer using hand gestures, including moving a cursor, opening apps, and sending messages by writing in the air as if using a pencil. The implications are enormous, especially for people with motor disabilities who may struggle to interact with computers using traditional methods. But what makes this wristband so special, and how does it work? The answer lies in a technique called surface electromyography, sEMG, which detects electrical signals generated by muscle activity to interpret user movements. These signals can sense a person's intended actions, even before they do them, making it a game-changer for people who have limited mobility. And this is the part most people miss. The goal of this wristband is not just to provide a cool new way to interact with computers, but to provide less invasive tools for people with motor disabilities. Meta is collaborating with Carnegie Mellon to test the wristband with people who have spinal cord injuries, enabling them to use computers even if they are unable to fully use their arms or hands. As Douglas Weber, a professor in the Department of Mechanical Engineering and the Neuroscience Institute, noted, even people with complete hand paralysis still exhibit some muscle activity, which means the device can interpret their intended actions. But here's the controversy. Some people may argue that this technology is not as advanced as other projects, such as Elon Musk's Neuralink, which aims to implant brain chips in individuals with severe paralysis. However, others may argue that Meta's wristband is a more practical and less invasive solution. The wristband is a simpler alternative to other projects, and its use of sEMG signals means it operates at a higher frequency than electroencephalogram (EEG) signals used in headsets. Meanwhile, Meta's wristband could be used immediately without surgical intervention, making it a more accessible option for people who need it. So, what do you think? Is Meta's wristband the future of computer interaction, or is it just a stepping stone to more advanced technologies? Let us know in the comments. And as we consider the potential of this technology, let's not forget to ask, what are the potential risks and benefits of using sEMG signals to control computers, and how might this technology change the way we interact with the world around us?